Hi everyone, welcome to Integral Calculus. Today we explore lesson 7.8, improper integrals. One integrals at infinities. An example is integrate x e to the x dx from negative infinity to 0. Negative infinity is not a real number, which is why it is called an improper integral. The way to do this integral is we're going to let t to be the lower limit. The upper limit is 0. And to get the negative infinity, we got to let the limit as t approach negative infinity. X e to the x dx. Well, to integrate this one, I'm going to use the integration by part. U equal x and dv equal ex dx. du is dx. V is ex. uv is xex minus the integral of v du ex dx. And we have limit t go to negative infinity. Limit t go to negative infinity of x ex minus e to the x. Evaluate from t to 0. Limit t to negative infinity. When we sub in the number 0, we have 0 minus e to the power 0 is 1. Sub in t, we have TET minus e to the power t. Yay. We have negative 1 minus limit t go to negative infinity. In order to evaluate the limit here, I'll get a quotient. We can rewrite this as t over e to the negative t minus 1 over e to the negative t. Well, use the property of limit. And we have negative 1 minus limit t go to negative infinity. T over e minus t minus this plus limit t go to negative infinity. 1 over e to the negative t. Negative 1. When we do the direct sub, we have infinity over infinity. Using the L'Hopital rule, LH, then we get limit t go to negative infinity. Derivative of the top is 1, derivative of the bottom is minus e to the minus t plus for the second part, this is just a direct sub here. 1 divided by number getting bigger and bigger is 0. Negative 1. Notice that the bottom is getting bigger and bigger and bigger. So just by doing the direct sub, we get 0. And hence, the limit is negative 1, which is the value of the improper integral. Okay, let's take a look at the second example. Integral from 2 to infinity, 1 over x squared plus 2x minus 3 dx. We can factor the bottom, and so this is going to be integration by partial fraction. 1 over x squared plus 2x minus 3 is equal to a over x plus 3 plus b over x minus 1. Do the common denominator, so have a times x minus 1 plus b times x plus 3 over x plus 3 x minus 1. We set the top equal to each other, so 1 equal to a times x minus 1 plus b times x plus 3. The best way to get the answer is let x equal 1. Then 1 equal to b times 1 plus 3. b is 1/4. And similarly, let x equal 2 minus 3. Then 1 equal a times minus 3 minus 1. So a is negative 1/4. Now we can do two things here. First, because infinity is not a real number, we're going to replace it by t. And we take the limit as t go to infinity. The partial fraction is negative 1/4 times 1 over x plus 3 plus 1/4 times 1 over x minus 1 dx. Okay. Limit t go to infinity. The antiderivative of 1 over x plus 3 is ln, so we have a negative 1/4 ln absolute value x plus 3 plus 1/4 ln absolute value x minus 1. Evaluate from 2 to t. We can condense them together and have limit t go to infinity. 1/4 ln x minus 1 over x plus 3. Absolute value x minus 1 over x plus 3. Evaluate this one from 2 to t is equal to limit t go to infinity 1/4 ln of t minus 1 over t plus 3. We can get rid of the absolute value because the expression inside absolute value is always positive for t more than 2. Minus 1/4 ln of 2 minus 1 is 1, 2 plus 3 is 5. Yay! Now we can put the limit inside ln. 1/4 ln limit t go to infinity of t minus 1 over t plus 3. And for this one, we'll use the property of logarithm, and we get plus 1/4 ln of 1 over 5 to the negative 1. Yay! So this 1/4 ln. The limit here is 1, and that is 1/4 ln 5. ln 1 is 0, and thus the answer is 1/4 ln of 5. Oh, slick. Let's take a look at another example. C. In this example, we have the integral of 2x over x squared plus 1 dx go from negative infinity to infinity. So in order to evaluate such integral, we have to break it into two integral. One can go from negative infinity to any real number. Let's just pick 0 here. 2x over x squared plus 1 dx, and the other one gonna go from 0 to infinity. 2x over x squared plus 1 dx. Let's evaluate one integral at a time. Okay. So for the first one, this just the u sub u is x squared plus 1. So du is 2x dx. And this would be limit t go to negative infinity of ln x squared plus 1 and go from t to 0. Okay, so limit t go to negative infinity ln of 1 minus ln of t squared plus 1. Yeah, so we know ln 1 is 0, so it's going to be 0 minus ln of limit t go to negative infinity of t squared plus 1. And this would be, we have ln of a number getting bigger and bigger and bigger. Well, infinity. One part of the integral is infinity, which is not a real number. We don't have to evaluate the other part. And we can say that the integral diverges. And that's the cool thing about computing improper integral. If one part diverges, then the entire integral diverges. The next kind of improper integral is integral having discontinuity. Two integrals having discontinuities. A integral from 2 to 5, 1 over square root x minus 2 dx. 1 over root x minus 2 is not continuous at x equal 2 because we cannot divide by 0. So the way to integrate this improper integral is we're going to let 2 to be t. Integrate from t to 5, 1 over root x minus 2 dx. And we take the limit as t go to 2 on the right side to ensure that the function is defined from t to the number 5. To do this one, we use the u sub that u equal x minus 2, and du is dx. And you will see that we have to change the limit here. Upper limit is 5 minus 2 equal 3. Lower limit is t minus 2. Yeah, So limit t approach 2 on the right side. Integral t minus 2 to 3, 1 over square root u du. Limit t approach 2 on the right side. The antiderivative of 1 over square root u is 2 root u. Evaluate this from t minus 2 to 3. Now we have limit t go to 2 on the right side of 2 root 3 minus 2 root of t minus 2. So we have 2 root 3 minus limit t go to 2 on the right side of 2 square root of t minus 2. We can figure the limit just by doing the direct sub. And that will give us 2 root 3 minus direct sub is going to give us root of 0. So in the end, we get 2 root 3. Pretty cool. Let's do one more. Integral from 0 to 3, 1 over x minus 1. The function is clearly not defined at x equal 1. So it is not continuous at x equal 1, meaning that we have to split this into 2 different integral. One integral from 0 to 1 on the left side of 1 over x minus 1 dx, and another integral from 1 on the right side to 3, 1 over x minus 1 dx. Yay. Now replace the 1 minus and the 1 plus by t and take the limit. Limit t approach 1 on the left side. Integral 0 to t 1 over x minus 1 dx. For the other one is limit t approach 1 on the right side. Integral t to 3 1 over x minus 1 dx. And the cool thing about improper integral is that we don't have to evaluate both integral. We can just evaluate one of them, and as long as one of them diverge to either infinity or negative infinity, then the entire integral diverge. Okay, so let's focus on the left side. Limit t go to 1 on the left side. The antiderivative of 1 over x minus 1 is ln absolute value x minus 1. Evaluate this one from 0 to t. Limit t go to 1 on the left side. Ln absolute value of t minus 1 minus ln absolute value of 0 minus 1. Yay! So this ln limit t go to 1 on the left side. Absolute value t minus 1 minus, well, that is ln 1, 0. And let's take a look at this one here. The limit as t go to 1 on the left side of absolute value t minus 1. That limit is approaching 0. So ln of a number approaching 0 is of course, approaching negative infinity. So we have negative infinity. Oh, negative infinity is not a real number. And does one side diverges? If one side diverges, then the entire integral is improper. Integral diverges. Thank you for watching. I hope you find the content useful. Please like, subscribe to help the channel growth. I will see you in the next video.